Welcome to this operations management tutorial video on forecasting. This is part 1 to a 4-part series of videos on forecasting, and in this one we will cover some basic time series methods of forecasting. We'll start by looking at a moving average example, then weighted moving average, exponential smoothing, and finally a trend projection. We're going to jump over into Excel and look at examples that can be found in the textbook as we walk through these methods. Again, we're starting with a moving average. We're going to do a 3-week moving average, and as it says in the textbook, we need to forecast what the demand is going to be in week 6. So we have actual demand in column C through the first 5 weeks, and we're going to take the 3 previous weeks and take the average of them for our 3-week moving average. So we simply type in the average formula, grab the 3 previous weeks, close parentheses, and there we have it. And lo and behold, the spreadsheet gives us what the actual demand turned out to be. So we're off by quite a bit, but this is our 3-week moving average forecast based on the 3 previous weeks of known actual demand. We can take that formula now and copy it down through the remaining cells, and now we have the forecast for week 7 and week 8 as well. We can see again that the forecast for a given week takes the 3 previous weeks, the average of the actual demand from the 3 previous weeks. Now let's move on to the 3-week weighted moving average method. To do this, we start by taking the demand from last week and multiplying it by the weight for last week. You'll notice that the 3 weights here added together equal 1, and that the weight for last week, 0.6, is twice as big as the weight for 2 weeks ago and 6 times as big as the weight for 3 weeks ago. The rationale is that data from the more recent time period, last week, is more reflective of what we think the actual demand is going to be. So that's why we have higher weights for more recent periods, but we don't want to completely exclude those further back weeks, and so that's why we're including them, but with lesser weight to them. Okay, we're also going to anchor the weight because we're going to copy this formula down and we want to keep the cell references to these existing weights here. So I'm going to hit F4, I'm on a PC. If you're using a Mac, do Command T. Okay, so there we have it. Demand from the previous week times the weight for last week plus demand from 2 weeks ago times the weight for 2 weeks ago, anchored, plus demand from 3 weeks ago times the weight for 3 weeks ago, anchored once again, and that gives us our forecast. And now we're going to copy that down as we go through the remaining periods here. Notice that the weighted moving average forecast is actually closer to what the actual demand turned out to be. And so that's one of the benefits of using a weighted moving average. If there's an upward trend, the weights will help you follow the trend a little bit better. All right, let's move on to the exponential smoothing method. This method is helpful when there's not a lot of historical data. In this case, we're going to hypothetically say we only have 1 week of historical demand, 42 units in the week of week 1. And we forecasted prior to that week that we would sell 50 units. That data then is used as we create the exponential smoothing forecast. The formula reads as this: F sub t, the forecast for period t, in this case period t is week 2. So the forecast for week 2 is equal to the forecast from period 1. F sub t minus 1, 2 minus 1, means the forecast from week 1 or the previous week. So the forecast for week 2 is equal to the forecast from week 1 plus alpha, which is our smoothing constant, times the demand, actual demand from the previous week, week 1, minus the forecast for week 1. So let's put this into our formula here. So our forecast is equal to the forecast from the previous week plus alpha, which we must anchor because we're going to copy this cell or this formula down, times, open a parentheses, the actual demand from week 1 minus the forecast for week 1, close parentheses, and that gives us 44 units. And we'll copy this formula down, and this gives us our exponential smoothing forecast for all of these periods. Finally, we're going to move on to the trend projection, and this is very simple using a correlation function or concept. We type in the trend formula, trend, open up a parentheses, the known y's. The y is the dependent variable, so our demand numbers are dependent on the time or the week. So we're going to take the actual demand numbers through week 7. Again, we're forecasting for week 8, so we have historical demand through week 7. It is the known y in this case, comma, the known x's are the time periods. We could use the week numbers or the actual dates. We'll use the actual dates through, again, week 7, not going into week 8 because we're forecasting for week 8, comma, and then we input the new x, which is July 12th, the new period for which we are forecasting, close parentheses, and that gives us a forecast of 134.3 units. Well, I hope this tutorial video has been helpful to you and will be helpful to you as you embark on the forecasting homework.